Hello everyone, I hope you are doing well. So in this video, we are going to discuss Geeks for Geeks problem of the day, and today's problem is nth node from end of the linked list, and it is an easy level problem. So usually on Sundays, I am busy with the Lead Code weekly contest in the morning. So on Sundays, you can expect the videos to come out a little bit late. Now let us quickly discuss the problem. The problem is not very difficult. It just says that we have been given a linked list and we have to return the data in the nth node from the end of the linked list, right? So if say this is the linked list and the value of n is 2, so the last node is this and the second last node is this, so we have to return 8 as an output. And there is one more example like this. Since in this case there are only 4 nodes and the value of n is 5, you have to return -1 because there will be no such node from the end of the linked list. This is our whole question. Now there are actually two ways to solve this particular problem. I'll tell you what are those ways. So let's say this is our linked list and it is connected like this. So the first way, which will not work in this particular case, is that I'm still telling you, because this is also one of the valid ways. It says that the value of n is too big for this particular approach to work. So what you basically do is you just have a recursive function. So let's say you have a function here, right? So you just call the function at the head. Now you just call the function on the next element and the next element and the next element, and whenever you reach null pointer, you mark your position as 1, right? So obviously when you have reached this particular position, now you will go back in the recursive loop, right? So you will automatically go back to this particular node. You will check whether this position is equal to the required position or not. If it is equal to the required position, you can just directly return your answer. Otherwise what you will do is you will increment the position and just go one step backward in the recursive function calls, right? So basically this will be your heap in which your recursive calls are stored. So it is like a stack. So this is the first node from the starting, this is the second node, this is the third node, and this is the fourth node, right? This all will be stored automatically for you. So basically whenever you reach null pointer, you mark your position as 1. So when you come back here, you see that your position is 1, but it is not equal to the required position. So just go back from here. It will automatically go back and pop this particular recursive function from the stack. So before going to this particular position, now you will increment post. So post can be any global variable which will denote your current position. Before exiting from this function, you can increment your position and it will become 2, and you can check whether position is 2 is equals to n. If it is equals to the required value n, you can just directly return the value at this particular node, right? Now again this will automatically pop out when you get out of this function, and before you pop out, their position will become 3, right? So this is how it works. But the thing is, the value of n is very large here. I believe it's up to 10 raised to power 5. For this particular value, the size of the stack will overflow and it will give you segmentation fault. I'll also show you how do we code this particular part, but it is not going to work. It will give you segmentation fault. I'm telling you because I tried this method. Now the other way to do this problem is, let's say you have a linked list like this. Since in this particular way, in this particular method, you already know, you never required to know the information from this particular node. How do you get back to this particular node? Because it is already stored in the recursive stack, right? So once this information is stored in the stack, what was the previous node, then you don't have any issues, right? But if we don't want to use this recursive method, then how do we actually know that from this particular node you have to go to this particular node, right? This information is now not available with us. So instead what we'll have to do is we'll have to reverse the linked list, right? So basically you just traverse one step forward, and in each step you just reverse the link, and when you reach the last node, you just initialize your position with 1. The same concept, initializing position with 1 and going to the next node like this backwards, and you increment your position. You just check whether it is equal to the required value of n or not. If it is equal, then you can just return its value. Otherwise you just go one more position back and increment your post value, right? Position value. So this is how you do this particular thing. The only difference between these two methods is that in this particular case, you already had all the information of the previous node in the recursive stack function, so you didn't have to explicitly know it. But here what is happening is, since there is no stack like this, you will have to reverse the linked list so that for each node you know what is the previous node. So these are the two methods you can solve this problem with. Now let us have a look at the code. So just let me show you my submissions also, because I want to show you that stack method or the recursive function method. So you see I have got runtime error here because this is the recursive style function that I was trying to create. So what I've done is I've created a function called traverse, and when I reach null pointer, I just initialize my position as 1. So my position is a global variable and answer is also a global variable. So I just try to like go to the next position by just calling traverse of next, and whenever like the current pointer reaches like this last position null pointer, I mark my position as 1. So you see this will just keep on calling the next element. Now whenever you return from this particular position, you will see, you will check whether position is equals to n. If it is equals to n, then I can just set my answer as current or data, and I'll increment my position. So you will see that it will automatically get out of this function from here, and it will go to the previous or the top of the stack function which was previously called before this particular value, and it will like keep on repeating this part at the end, right? This is obviously going to give you segmentation fault or runtime error as we are seeing here. So the correct approach and the final approach would be the last one that I have submitted. And here you see that what I've done is I've like returned the reverse. This is my reverse function which is going to reverse my linked list and also going to generate my answer. So I'm just passing my head pointer. Now I just initialize my previous pointer as null pointer, and I'm receiving my current pointer. So while current is not equals to null, what I do is I just create a new temporary variable or a new temporary node which will store the address of the next node of the current node. Now I set my current dot next is equals to previous, and I'll update my previous with current. And now I'll also update my current as temporary, which was initially the next of the current variable or the current node. So at the end, my last node visited will be at previous, and my current will have null pointer. So I just set my current as previous, right? And I initialize my position with 1. Now I just try to traverse the linked list in the reverse order. So I'll have my detail in current dot next, right? So essentially the element which was let's say we have a node x and there was a previous node y to x. Now x dot next will be equals to y, right? So we have reversed the linked list. So I just run this particular loop while current is not equals to null pointer. If position equals to my required position n, and I can just return current dot data. Otherwise I will increment my current actually going backwards, and I'll increment my position. So at the end, like if I have not found any position suitable to n, I'll just return -1, right? So this would be the solution of today's problem of the day. I hope that you guys were able to understand the solution. If you guys did, then consider dropping a like on this video, and don't forget to share the channel with your friends and also subscribe to this channel. I see a lot of people who watch these videos have not subscribed yet. So if you're one of them, then consider subscribing. It's always free of cost, and you can always unsubscribe later if you don't find the videos interesting. So till the next video drops, keep coding, stay safe, bye bye.